Hi everyone, this is the last lecture in Unit 3. Today we're doing Lesson 3.4, Optimization Problems in Economics and Science. Today's sample problem is not from your learning resources. A cylindrical can is to hold 20 pi meter cubed. The material for the top and bottom costs $10 per meter squared and the material for the side costs $8 per meter squared. Find the radius and the height of the most economical can. In other words, we're trying to minimize the material used and thus minimizing the cost. Solution: let R be the radius of the cylindrical base and H be the height of the cylinder. The total volume of the cylinder is given to be 20 pi. And that will be equal to the area of the base times the height. Area of the base is area of the circle, which is pi r squared, times h. If we rearrange this equation, we will get the radius in terms of h. So height will be equal to 20 pi over pi times r squared. The pi's can be reduced, and that will be equal to 20 over r squared. Remember, keeping in mind that we wish to minimize the total cost of the construction of the cylinder. The cost will be equal to the total cost of the bottom plus the total cost of the top plus the total cost of the side. That will be equal to $10 times pi r squared plus $10 times pi r squared plus $8 times 2 pi rh, which will be equal to 20 pi r squared plus 16 pi rh. We've already mentioned that h is equal to 20 over r squared, so we plug that into this equation, and that will give us 20 pi r squared plus 320 pi over r will be equal to c. Now we have to find the critical points, therefore we have to find the derivative of c. The derivative will be equal to 40 pi r plus 320 pi times in bracket -1 over r squared. We try to find out for what value of r will c prime be equal to 0. That value will be our critical points. And that occurs when r is equal to 2. If r is equal to 2, we get h is equal to 20 over 2 squared. H will be then equal to 5 meters. The cost will be then equal to 240 pi, which is approximately $754. Here we have the summary for optimization in economics and science. Profit, cost, and revenue are quantities whose rates of change are measured in terms of the numbers of units produced or sold. Economic situations usually involve minimizing cost or maximizing profit. To maximize revenue will be equal to total revenue from the
X unit minus the price per unit times X. And that's the end of this lecture. Thank you guys for watching.